So, order of operations. Now, to start off, yes, we all recognize this as GEMDAS. If we maybe recognize it as PEMDAS, know that the P has really changed to a G. That's okay. First thing we're going to start with is, okay, well, what are the order of operations, right? We've already been told there's sort of like that procedure or a way to organize our work, as Shai was saying. But more specifically, it is, or they are, rules for computations. So rules for computations that mathematicians agreed to avoid errors. And so again, rules for computations that mathematicians agreed to avoid errors. And so what order of operations says, right, is that certain things just get a higher priority when solving or simplifying. Certain things get a higher priority when solving or simplifying. If mathematicians wanted to, when they were agreeing upon rules to basically avoid ambiguous arguments like we saw in the do now, they could have said, you know what, just work everything left to right. In which case, the order of operations would be a very different conversation where I'd be writing down, you work things left to right. That's just not the case, though. Prosper question. Yes, mathematicians agreed to avoid errors. Yes, that's meant to be there twice. Thank you. And so now we've actually already heard, right, from Terrell what these are. We just want to stamp them. And so our G, these are groupings. Now, groupings come in many different forms. They come in many different forms. This is part of this shift away from P for parentheses because it's just not inclusive enough, if you will. And so possible symbols we might see that constitute a grouping. You might see a radical, right? We started to see those yesterday. They might be parentheses. It might be a fraction. It could be bars on the outside. Raise your hand. If we have bars on the outside, do we know what that is? Shai? Absolute value, 100%. It might be absolute value. That counts as a group. Or it might just be brackets. Brackets, similar as parentheses. We'll see in domain and range that it's a little bit different. However, for now, going to be a similar use. Zoom out or zoom in? Start with me here, and then I'll make sure you get the top one. All right, so that's our G. E, again, already named for us. These are exponents. And so if we have some sort of expression that has an exponent that we are looking to solve, biggest thing, you just have to do the exponent first. And so things you might see, 4 squared divided by 2. This square needs to be the first thing that we attend to. If it is not, we are not properly following our order of operations. Okay, well, let's just solve this. Raise your hand. What is 4 squared? Come here. 16. So we have 16 divided by 2. Okay, well then that's just division. Everybody, 16 divided by 2 is? Ooh, careful. Make sure we got 8. Make sure we got 8. All right, bring it back. And so again, we have to do that exponent first. I am not allowed to do 4 divided by 2 and then square it, right? Again, we'd be ending up with a different and incorrect answer there. Now, M/D, this is multiplication and division. Now, the big headline for multiplication and division and addition and subtraction when we get there is truly left to right. If you have only multiplication or division left, you just go left to right. And so, I'm going to name that. If we have something that looks like 8 divided by 2 times 6, again, we're just going left to right here. And so the first thing I'm actually going to do is that 8 divided by 2. So I'm going to end up with 4 times 6. Now I'm going to do that multiplication to get an answer of 24. Again, making sure we're working left to right. And as I've already said, addition and subtraction, it's the same setup. Again, we work these left to right. And so if I have something like 4 minus 2 plus 3, starting with the 4 minus 2 for 2, and then plus 3 for 5. All right, starting to hear it. Once you've got that last one, put pencils down so that I can see. Thank you. There. Thank you. All right. Now, we're going to start with one example. And so go ahead, flip your notes, and look at example 1, please. Now, for example 1, I'm just going to do a think aloud model. And so I'm truly just going to think out loud about what I would do when I approach this problem. All right, I know that I have to evaluate this. Looking at this, I know that order of operations is going to be extremely important. There is a lot going on. And so the first thing I'm actually going to do is annotate my order of operations, okay. G, E, M, D, A, S. Now, as a reminder to myself, when I annotate these, I like to put arrows above MD and AS. Again, just as a reminder that when I get to just multiplication and division, I'm going to work left to right. And when I get to just addition and subtraction, again, I'm going to work left to right. Okay, G, groupings. Taking a look, especially based on what we just put, I see a square root symbol, right? I see a radical. I have this section right here, which is my grouping. Which means I have to deal with that section first. That needs to be the first thing I do. Okay, well, inside of that, I have 64 divided by 4 squared. Okay, I have division, and I have an exponent. I know that, again, if I go back and look, I need to do my exponents before my division. And so, in my next line, the only thing I'm actually going to do right now is I'm going to have 64 divided by, well, 4 squared, we actually already did this one together, is 16. From there, everything else is just sort of along for the ride. Plus 8 times 2 minus 5, until I get this group cleaned up. Okay, well, now I just have division left in the group. 64 divided by 16, I know that that's 4. And so I know this is actually the square root of 4 plus 8 times 2 minus 5. Now, even though there's no more work to be done inside the group, I still need to take care of the grouping symbol, right? I still have the radical there, or the square root. Well, I know that the square root of 4 is 2, so I'm going to have 2 plus 8 times 2 minus 5. Okay, and so at this point, I actually know my groupings are done, and I have no more exponents. And so now I'm working with multiplication, and then I have addition and subtraction. Well, okay, multiplication first, I can do that. 2 plus 16 minus 5. Well, there's no more multiplication and division. That's done. I have only addition or subtraction, and so I'm just going to go left to right. Well, 2 plus 16, that's 18, minus 5. 18 minus 5 is going to get me to 13. So that 13 is going to be my final answer there. What questions do we have on solving an expression like this right now? All right, then you're going to get a chance to practice this. We're going to pause on example 2, and I actually want you to jump back into your packets and take a look at problem set A.